So for problem 66, we're trying to answer questions about the function f given the graph of f prime. Here we have the relationships between f prime, and f double prime. For part A, we're trying to find when f is increasing. So if we want to know when f is increasing, we have to look at the sign of f prime. Well, I find it easier to answer these questions if I make my own sign chart. And first thing we want to do when we create our sign chart for f prime, we create our f prime test. It's a sign chart for the sign of f prime. We just look at the graph of f prime and we see, well, where is f prime equal to 0? And the first spot, first x coordinate where the f prime is equal to 0 is -2. And then it's also equal to 0, f prime is, when x is equal to 1. So on the interval, we have a closed interval here from -4 all the way to 2. So we have on the interval from -4 to -2, f prime graph is above the x-axis, therefore the sign of f prime is positive. F prime graph is also above the x-axis between -2 and 1, and it's below the x-axis between 1 and 2. So therefore, f would be increasing on the interval from -4 to -2, as well as from -2 to 1. So let's answer that question right here. So from -4 on the interval, from -4 to -2, as well as from -2 to 1. And then we want to figure out where f is concave up. Well, f is concave up where f double prime, so here concave up, where f prime is increasing, and where f double prime is positive. So if we create an f double prime test, then it looks just like the stuff we've done before. In fact, makes it a lot easier to try to, I guess, summarize f double prime when we write it down in a format, like I said, like we've done before. So what you're looking for here is, again, f double prime test. If f is concave up, then f prime is increasing. So we know and we understand increasing and decreasing. So we see, let's figure out first of all where f double prime, which would be the slope of, and let's write that down, slope of f prime, where the slope of f prime is equal to 0. So we see we have two critical points on the for the f double prime test. The critical point for an f double prime test would be where f double prime is equal to 0. In other words, the slope of f prime equals 0. That would occur at x equals -2, and then at x equals 0. So we have f double prime equals 0, f double prime, slope of f prime equals 0 at both of those values, nowhere else. On the interval from -4 to -2, f double prime, the slope of f prime is negative. In other words, f prime is decreasing. So f prime is decreasing. That means that f double prime is negative. And then on the interval from -2 to 0, the slope of f prime is positive. So f double prime is positive. And then on the interval from 0 to 2, f double prime, or the slope of f prime, is again negative. So therefore, f then, if we want to draw a picture, we drew a picture of f on the f prime test when f prime is positive. F is increasing, f is decreasing when f prime is negative. But then when f double prime is negative, f is concave down. And then when f double prime is positive, f is concave up. And again, f on the interval from 0 to 2 is concave down because f double prime is negative. So therefore, the question that we're answering for part B is, where is f concave up? Well, that's on the interval from -2 to 0. So you'll train your eyes to see, oh, when f prime is increasing, f is concave up. F prime is increasing, that's right here. F prime is increasing, f is concave up. All right, so when we're looking at the graph of f prime, there's no work to do other than understanding how to interpret the graph. And then, where does f have a relative extreme value? So we have extreme values when f, are we answering questions on the interval from -4 to -2 or to +2? So I'm looking at that. So f has an extreme value when x is equal to negative 4. At x equals negative 4, we have a relative min. At x equals negative 2, we have a horizontal tangent line, but f goes from increasing to increasing. F prime doesn't change sign. So if f double prime doesn't f prime doesn't change sign, then we have no extreme value. But we notice over here when x is equal to 1, f prime changes sign from positive to negative. So basically the graph looks like up, up, and then down. We're not really sure how low it is, how low f of 2 is, or how low f of negative 4 is, but we do know that we have an absolute extreme value, absolute maximum at x equals 1. We have no way of knowing, unless we were given other information, whether or not we're going to have a, let's see, what the y values would be. So we just know that when x is equal to 1, we have a max. Now that max happens to be an absolute based on what we talked about before. And then we also have a local min when x is equal to 2. X is equal to 2, we have a min. Now again, we're not sure how high up or down, how high f of negative 4 is or f of 2 is, so we're not sure about about whether those are absolutes or relatives. But then where does f have an inflection point? Well, if you know the definition of an inflection point, when f double prime changes sign, f double prime changes sign at x equals negative 2, as well as at x equals 0. And that is it.